Triangle ABC has sides x, root x, and x squared, where x is an integer. What is the area of ABC? Very interesting. So let's think about possibilities for x. First of all, a side can't be negative and it can't be 0. So x has to be a positive integer. It certainly is possible that x would equal 1. Then we'd just have sides of 1, 1, 1. That would be an equilateral triangle, a side of 1. What if x equals 2? Well, then we'd have sides of 2, square root of 2, and 4. And we run into a problem here because, of course, 2 plus the square root of 2 is less than 4. And this violates a rule in geometry called the triangle inequality. The triangle inequality says that the sum of two sides always has to be longer than the third side. Here, if we had a side of 4, the poor side of 2 and root 2, they would never reach. And so you wouldn't be able to close the triangle. And of course, that problem is only going to get worse when x increases to 3, 4, and 5 because the squares get really big. And so they're much bigger than the number plus the square root. And so none of these cases work at all. The only case that works is the case where we have an equilateral triangle of side of 1. So it will be possible to figure out a unique area. Now the question is, if we have a equilateral triangle of side 1, how do we figure out its area? Well, we talk about this in the geometry videos, but I'll just remind you, what we do is we draw a diagonal. And of course we draw an altitude. And this, of course, splits the angle, so this is 60. And what we have here is a 30, 60, 90 triangle. This part right here is 1/2. And that means that that height is the square root of 3 over 2. And so now we can figure out area equals 1/2 base times height equals 1/2 times the base, the whole base, which is 1, times that height, which is that square root of 3 over 2. Multiply the numerators, we get square root of 3. Multiply the denominators, we get 4. And so the total area is square root of 3 over 4. Answer choice C.
Okay, to begin, please notice that we have two angles opposite each other at an intersection. As such, these two angles must be equal, in which case column B must be 75. Now notice that we have two lines here that appear to be parallel. However, since we are not told that they are parallel, we cannot assume that this is the case. Now let's consider one possibility that they are parallel. If this were true, then this angle here would be 75, which would make angle X 105 degrees. In this case, column A would be greater than column B. However, as I said, we cannot assume that these two lines are parallel. So it's quite possible that we could move this line as follows, such that column B is now greater than column A. So since we cannot be certain which column is greater, our answer here must be D.
Now this problem, we could take an algebraic approach. We could call the shorter leg x, and then the hypotenuse would be x plus 16, and we could try to use algebra. The unfortunate thing is that algebra leads to a dead end. It leads to a cubic equation that is not easy to solve. And so really this problem is designed to be ideal for back solving. And so that's how we're going to solve it. And with back solving, we always start with the middle number. Here's C, for reasons that if it's too big, we know what to eliminate. If it's too small, we know what to eliminate. So let's say that the hypotenuse is C. It is 40. Well, the short leg is 16 less than that, so that's 24. And notice that 40 equals 5 times 8, and 24 equals 3 times 8. And so really what we have here is a 3, 4, 5 triangle, and so the missing side would have to be 4 times 8, or 32. And so that would be the triangle. What's the area of this? Area equals 1/2 base times height. 1/2, 24 times 32. I'm going to write this as 12 times 32. Well, 12 times 32 is obviously bigger than 10 times 30, which is 300. So this is much, much bigger. And so right away we know not only does C not work, but D and E can't work either. All three of those are way too big. And so we've eliminated 3 answers right away. So now we're just left with 2 answers, A and B. Let's say we try B. So now the hypotenuse is 32. The leg is 16 less than that, so that is 16. And notice this is a scaled up version of a triangle with a hypotenuse of 2 and a side of 1. And of course, what would be the third side of this? Well, you may recall this is a 30, 60, 90 triangle, so the missing side is root 3. This is just multiplied by it, so it is 16 root 3. Now right here, notice that I'm not even going to bother finding the area. The area is going to be a radical. And we know if the area is exactly 120, that's not a radical, so we know this is not coming out to be the right answer. Also, 8 times 16 is 128, times root 3 is going to be more than 120, so this is going to be too big also. And so for a variety of reasons, B does not work either. And so we can eliminate B. And so by process of elimination, it appears that A is the answer. Now, if we were rushed for time, we would just pick A. Let's say we had a little more time and we just want to verify, just make 100% sure that A does work. Okay. Well, if this is 26, this is 10. And notice that both of these are multiplied by 2. So 10 equals 2 times 5. 26 is 2 times 13. Well, this is a 5, 12, 13 triangle. That is one of the Pythagorean triplets. That's good to know. 5, 12, 13. So the missing side has to be 2 times 12, or 24. When we find the area of that, 1/2 base times height, 12 times 10, is 120. And so this does have an area of exactly 120. And so indeed it is true that A is the answer.
To solve this question, we're going to use the following rule. It says that if A and B are the lengths of 2 given sides of a triangle, then the length of the third side must be greater than the difference between A and B and less than the sum of A and B. So let's begin by finding the difference between the 2 given lengths. This will be equal to 3x plus 4 minus 2x plus 1, and this is equal to x plus 3. Now let's find the sum of the 2 given lengths. This, when we simplify it, will equal 5x plus 5. So the length of the third side must be greater than x plus 3 and less than 5x plus 5. At this point, we'll check each of our answer choices and determine whether or not it is greater than x plus 3 and less than 5x plus 5. Let's begin with A. Well, here we can see that 4x plus 5 is greater than x plus 3, and 4x plus 5 is less than 5x plus 5. So answer choice A is a possible length. What about answer choice B? Well, here x plus 2 is not greater than x plus 3. In fact, x plus 2 is 1 less than x plus 3. So answer choice B is not possible. What about answer choice C? Is 6x plus 1 greater than x plus 3 and less than 5x plus 5? The answer is sometimes. For example, when x equals 1, 6x plus 1 does fall within that range. However, when x equals 10, 6x plus 1 does not fall within this range. Now, the question asks us to find possible lengths. So since it is possible for 6x plus 1 to fall within this range, answer choice C is possible. What about answer choice D? Well, here we can clearly see that 5x plus 6 is definitely greater than 5x plus 5. So answer choice D does not fall within the right range. And finally, we have answer choice E, which is a lot like answer choice C, in that sometimes it falls within the required range of values, and sometimes it does not. For example, when x equals 1, 2x plus 17 does not fall within the range. However, when x equals 10, it does fall within the range. So since it is possible for 2x plus 17 to fall within the required range, answer choice E is correct, and our 3 correct answers are A, C, and E.
Equilateral triangle has an area of square root of 3. If the shaded region has an area of pi k minus the square root of 3. What is the value of k? Give your answer as a fraction. Well, the first thing we need to do is find the side of the equilateral triangle. And here it's helpful to know the formula for the area of an equilateral triangle. If s is the side, then the area of the equilateral triangle is s squared root 3 over 4. And so if this equals square root of 3, it's very easy to see that if we divide by both sides by square root of 3, we get s squared over 4 equals 1, s squared equals 4, s equals 2. Of course, it has to be positive because it's a length. So the triangle, every side of the equilateral triangle equals 2. So that's helpful. That's not the answer in and of itself, but that is helpful. So now let's think about this. This is 2, this is 2, this is 2. And what we really want is the area of the circle. Well, we can always divide an equilateral triangle by this. Draw 3 altitudes. And this divides the triangle into 6 30, 60, 90 triangles. So this side here is 1. Let's call this point D. From D to C is 1. In fact, I'll even draw this little, let's call that O. We'll expand this here. We have point D here, point C here, O here. This is 1. This side, this is the long leg. The short leg is the long leg divided by the square root of 3. So it's 1 over root 3. I'm not going to bother to rationalize. I'm just going to leave it like that. And then the hypotenuse is double the short leg. So that's going to be 2 over root 3. But here's the amazing thing. Look at OC in the big diagram. O is the center of the circle. So OC is the radius. That's the radius of the circle. And of course, the area of the circle, we know, is pi r squared. So pi times that, well, we get 2 squared is 4 in the numerator. Square root of 3 squared is 3 in the denominator. So the area of the circle is 4/3 pi. And therefore, the area of the shaded region is 4/3 pi minus square root of 3. And so k equals the fraction 4/3.